Hello guys, today I want to start a video by thanking all of my subscribers who are already more than 100. You are the people who motivates me to take these videos. Today we will discuss IMO Shortlist 2021 A2. In this problem, we need to find all n such that I times j over n plus 1, lower bound of this number, the I is from 1 to n and j is from 1 to n, equals n squared times n minus 1 over 4. At first notice that if we consider two numbers, I times j over n plus 1 plus I times n plus 1 minus j over n plus 1, this lower bound equals either I or I minus 1, because we know that if we take the sum of these two numbers, this is I, and if we split this I into two separate numbers, we must get at most decreased by 1 if we take their lower bounds. And where can we get this I? If any of these numbers, if I times j is divisible by n plus 1, we will get the case then this equals to I. Or for all other cases, we get that I minus 1 if I times j is not multiple of n plus 1. And now take the case there we have always I minus 1 in such pairs, and now try to count what will be our sum. So we will have I sum of the I n over 2 times minus n over 2 n over 2. This would be for each row if we fix some constant number I and we change only j. Clearly this can be occurred for this pairing, this one and this one. And if we change I also, we get sum of the numbers n over 2 times I minus n squared over 2. Sum of the i's equals clearly n times n plus 1 over 2. So we get n squared times n plus 1 over 4. And we need to subtract number n squared minus n squared over 2. And if we find the common denominator, we get that this equals n squared times n minus 1 over 4. So this looks like this is almost same as our right hand side of the initial equation. So we have proved that in all of our pairs we get I minus 1 for this sum. Otherwise we will see that our final sum would be more than n squared times n minus 1 over 4. So if at some point we have found such j that I times j is divisible by n plus 1, we can see that left hand side would be more than right hand side. So such I and j cannot be found. But if we know that n is not n plus 1 is a composite number like p times q, we can always choose this p and q. So the only remaining point will be that n plus 1 must be prime number for some number p from the set of primes. And if we discuss p from the set of primes, we will see that this works. If we take this sum of the pairs, we get that sum of the whole grid would be n squared times n minus 1 over 4. So this was all I want to discuss for today. By this video I will finish the playlist of the problem of the day, and for the next day I will propose you different and interesting topics. If you want to continue my channel, please like and subscribe.